Okay, so welcome to, I think it's lesson number 24, and we're currently kind of carrying on with our trig. We're doing loads and loads of practice, all right? So let's take a look at this. It says without a calculator, no calculator. And that means that we're either going to be using special angles, or we're going to be able to get rid of things that we don't know by using double angle formulas and co-ratios and things. So let's just take a look at this question. What we see over here, we see a sine of 80 degrees, right? Now, yeah, that's not particularly interesting. Let's look at this. This is cos of 220. Let's reduce these two as a starting point, okay? So cos of 310, we are in quadrant 4 by 40 degrees off the vertical axis. So sine of 40 degrees, right? Remember our all sine tan cos diagram, okay? And cos 220, we're in quadrant 3 by 40 degrees. Cos is negative in quadrant 3, so we're going to put a negative in front of there, and we're going to go negative cos 40 degrees. Now, this is where it really helps to know our rules really, really well. This is our double angle identity. It sort of looks like it. On the top, we've got sine of 80. Now, 80 is sine of two lots of 40. I don't know what sine of 40 is, right? Nor do I know what cos of 40 is without a calculator. But now we can use our double angle formula, and we get 2 sine 40 cos 40 on the numerator, and on the denominator we get negative sine 40 degrees cos 40 degrees. Okay, and now we can divide the top by cos 40 and the bottom by cos 40, the top by sine 40 and the bottom by sine 40, and we get a final answer of negative 2. Can we check that using our calculator? Of course we can, right? But to get full marks for this question, we need to show that we've done it without a calculator. Okay, let's look at the next one, B. And maybe if you haven't tried it, pause the video and try it. But let's take a look. But these questions, both of these involve the number 7, all right? Cos squared 173. Now, cos is actually negative in quadrant 2. We're 7 degrees away from the horizontal axis, but then we're going to square it anyway. So this is actually cos squared 7 minus sine squared 7. And what is that? What is cos squared minus sine squared? Which one is it? That's right. That's actually the cos of two lots of 7. That on the top there is the cos of 14. Okay, so on the top we've got the cos of 14. Let's have a look at what we've got on the bottom. Sine of something, cos of something, cos of something, sine of something. Let's reduce and put into the first quadrant all these angles. Sine of negative 66 is the same as negative sine 66. Cos 190, we're in quadrant 2 by 10 degrees. All right, quadrant 2 by 10 degrees. In quadrant 3. In quadrant 3, cos is negative, so this is actually we're going to change that back to a positive. So this will be the same as cos of 10 degrees. Now, cos of 66, that's fine. We're going to leave that exactly as it is because we've already got a 66. But sine of 350, we are 10 degrees into quadrant 4, all right, off the horizontal axis, and sine's negative. So this is actually going to become plus cos 66 sine 10. Sine 10. Okay, and so on the top we've got cos 14. On the bottom we've got sine something cos 10 plus cos something sine 10. That is exactly sine of 66 plus 10. Right, so in fact what we've got on the denominator is sine of 76. So we've got cos of 14 and we've got sine of 76. Now those aren't special angles, but 76 is 14 away from 90. So we can change sine 76 to cos of 14. All right, in quadrant 1 off a vertical axis. And we put cos 14 over cos 14. Final answer, 1. Okay, and again, we could check it with a calculator. All right, we're going to ask you to pause the video and we're going to ask you to try these two. Okay, so this first one, we're going to reduce again. Okay, so sine 25. Now sine 175 is actually the same as sine of 5 degrees. We're 5 degrees away from a horizontal axis and sine's positive in quadrant 2. Now this one's already at 25. Cos of minus 25, we're in quadrant 4 and it's just the same as positive cos 25. Alright, now we've got sine, sine and cos. Let's have a look here. Let's try and involve a 5 degrees because we've got a 5 degrees. Okay, so this is in quadrant 4. Sine's negative in quadrant 4, so we must change this here to a negative. And if we come off a vertical axis, we must change this to a cos. Now this looks almost like, so we've got sine, sine minus cos, cos. Remember that the cos compound angle formula actually is the other way around. So let's factor out a minus. Cos 25, cos 5, minus sine 25, sine 5. Okay, and that is cos of 25 degrees plus 5. And 25 plus 5 is a special angle. So in fact, we're going to get negative cos of 30 degrees. Cos of 30 degrees, root 3 over 2. Negative root 3 over 2. Okay. All right, and the last one. Let's take a look at this one. Okay, again, we're going to try and reduce things. That is just 4 degrees away from an axis. So is that. So let's play around with 4 on the top. This is going to be negative sine 4 degrees. And this is going to be negative cos 4 degrees. Now the reason I'm writing a bracket is so that I don't think it's a subtraction. It's not negative sine 4 minus cos 4. It's negative sine 4 times negative cos 4. Okay? On the denominator, we've got sine squared and we've got cos squared. Now, that sine squared of minus 41 is actually in quadrant 4, but when we square it, it's actually going to be exactly the same as sine squared 41. And this is going to be exactly the same as cos squared 41. Okay, now we've got sine squared minus cos squared. Okay, so let's take a look at this. On the top, we've got sine 4 cos 4. On the bottom, we've actually got the negative of cos squared 41 minus sine squared 41. And that is our double angle formula for cos. That's actually the same as cos of 2 lots of 41. 2 lots of 41. And on the top we've got, this looks like half of sine of 8 degrees. Because remember, sine of 8 would be sine of 2 lots of 4, be 2 sine 4 cos 4, but we haven't got the 2, so it's half sine 8 degrees. On the bottom, we've now got negative cos 82. And on the top, we've got a half sine 8 degrees. But cos of 82 is exactly the same size as sine of 8 because we're 8 degrees away from a vertical axis. So we get half sine 8 And on the bottom, we've got negative sine 8. Cos 82 and sine 8 are exactly the same size. These divide out, and we get a final answer of negative a half. Okay, so yeah, all of this manipulation, not all that easy, but it comes with practice, and we do need you to learn your identities. We're now going to use our new identities to solve some equations, right? And so here's an equation, solve this. Wow, it looks awful. It looks awful unless you've learnt your identities. If you've learnt your identities, you will straight away pick that that is sine of theta minus 30 degrees. Now, to me, it looks very straightforward, very plain, very vanilla, okay? Remember what we're going to do? We're going to find a key angle. The key to finding a key is not to put the negative into the calculator. All right, we're just going to undo sine of a half, and we get 30 degrees. Then we say to ourselves, which quadrants do we want to be in? Well, we want to be in quadrant number, for sine to be negative, we want to be in quadrant 3 and 4. So one option is going to be 180 plus the key, and the other option is going to be 360 minus the key. Both of those can have 360 added to them. Okay, I'm doing a general solution here. We don't really need the general solution for this one. And this is not theta, this is theta minus 30. So theta minus 30 is that, or theta minus 30 is that. So in fact, our only answers are going to be, if we add 30 to both sides, we're going to get 240 plus 360k, or 360 plus 360k. There are only two answers between 0 and 360, and we can see that because the period has not changed. So we're expecting two answers, and there they are. Right, can we check them? Yeah, we could put them into a calculator and check them. Let's look at this one. Now this one over here, we've got 3 cos 2x plus sine 2x minus 1. Okay, now let's see what we might be able to do here. This looks interesting. Okay, we could potentially change this into some cos squareds and sine squareds. All right, we could change this into cos squared x minus sine squared x. This is 2 sine x cos x. This is minus 1. All right. Now, what we're going to do, instead of 1, we're going to write our 1 as sine squared plus cos squared. Okay, we're going to see why now. All right. This is tricky. All right. Because what we're going to get here is we're going to get 3 cos squared x. Then we're going to get minus this cos squared x. We're actually going to get 2 cos squared x. Then we're going to get our plus 2 sine x cos x. Sorry, this is equal to 0 on the right hand side here. Guys, just understand what we did here. This 1 became sine squared plus cos squared. What I'm looking for here is a trinomial in sine and cos. So we're going to get 2 sine x cos x here. Then we've got negative 3 sine squared x minus another sine squared x. So we've actually got minus 4 sine squared x. And that equals 0. Okay. And so now, what we've got, if we divide everything through by 2, we've got cos squared x plus sine x cos x minus 2 sine squared x. And this can factorize into 2 brackets like this. We can put a cos x and a cos x. They will multiply together to give us cos squared x's. And then at the back, we're going to put some sine x's. And those will multiply together to give us sine squared x's. And the products of the sines and coses will give us that. We want minus 2 sine squared x. So we must have minus 2 and plus 1. Now if we look at this, it looks like we've got something wrong here, because we've got, cos, we need this to be a negative sine x cos x. Let's just have a look. 3 minus 1 is 2. 3 cos squared x, sorry, 3 cos squared x minus a cos squared x. This is also 2, sorry. Okay, so in fact this is actually cos squared x plus sine x cos x minus 1 sine squared x. Sorry guys, it was actually minus 4. Yeah, it just doesn't look like it's going to factorize. That's what's causing us a bit of grey hair here. It might be that the question's got an error in it. Let's just have a look. Three cos squared x minus a cos squared x, 2 cos squared x. Negative 3 sine squared x minus another sine squared x is minus 4 sine squared x. And then we've got our 2 sine x cos x. Right, so it becomes cos squared x plus sine x minus 2 sine squared x. Okay, I think this can actually work. I think we need to go cos x and cos x, and then we need to go plus 2 sine, sorry, plus 2 sine x and minus 1 sine x. And what we now get is that cos x equals sine x, or that cos x equals negative 2 sine x. Okay, so cos x equals negative 2 sine x, or x equals sine x. Now both of these are of the type where we've got sine and cos acting on the same angle. Do you remember what we do with these? That's right, we divide both sides by tan. So for this one we're going to get tan x equals negative 2. Sorry, we're going to get 1 equals negative 2 tan x. We're going to get tan x equals negative a half. And for this one, we're going to get tan x equals 1. Right, for both, we find the key angle. We get into the right quadrants. The answers for this one are 45 degrees or 225 degrees. That's in quadrant 3. And the answers for this one are 63,4 is the key angle. We want to be in quadrants 2 and 4. So 116,6 degrees. And if we add 180 to that, we're going to get 296,6 degrees. Okay, and there are the 4 answers to that. Okay, that was tricky. Okay, we're going to ask you to pause the video and try these ones before. In fact, we're going to end there. There are 6 more, all right, which brings us to the sort of the end of a big section of trig. Just one last little piece of trig to do. All right, try these and try them before we next see you, and then we'll go over them next time.